Right. All right, good evening. We'll start. Am I loud and clear? Okay, audio is fine, right? We'll start. Am I loud and clear? Okay. Okay, it's very fine. So we are going to start the last session. This is a special day, right? Last session that you are going to have with me as a live session before you are sitting for the exam, right? The last live session you are going to have before you sit for the exam, right? So it's kind of an end, right? After this session, right? That is going to be a complete end actually, right? And we are allowed only do classes up until 12 a.m. only, 12 midnight only today. So I have to finish the session before 12, right? We have to finish the session before 12. Right? So as a session, this is a special session because this is the last session we are going to have as a live session, right? So far about these YouTube sessions I have conducted, I have finished 25 S2A sessions, right? 25 days of S2As, and this is the 4th day of essay questions. And other than that, you were with me for 5 practical seminars, right? So other than that, some other special lessons were given, special lessons, right? So those are things we have been doing, and after today, we are not allowed to do any such thing as a class, as a live class today after today, right? And the paper discussions we had, right? Yeah. All right. Then so it will be the last day today, right? It will be the last day today after this, and today I thought of discussing properties of meta questions, and especially surface tension and viscosity. Now, last time we all know that elasticity has come, right? It came. So therefore, the probability of coming surface tension or viscosity is a little bit high, no? Right? Especially something like surface tension. So therefore, I thought of discussing questions from surface tension and viscosity, right? But that doesn't mean elasticity is never going to come. That we can't say, right? That we can't say, right? Even though that was there the last time, even, right? Uh, it can come this time also, right? There had been such cases about the other questions also, right? So therefore, that we can't assure that it is not going to come anything from elasticity. No, that we can't say, but the higher possibility or higher probability is with the higher possibility or higher probability is with surface tension and viscosity, or a combination of those two, right? Then without further ado, let's go to the discussion, right? Because today we have a limited time, right? So whatever we do, we have to finish before 12. Okay, that is the previous paper, this one, right? Okay, if there's anyone who didn't get this, right? If there's anyone who didn't get this, you can get it from the channel. You can get it from the channel, right? So otherwise, these are the past paper questions, no? So you can refer your own book or something, right? If not, if you need this document, you can go to my Telegram channel and get it. Okay, so this is 24 one. I'm going to start first, right? This is the 24 question. I'm going to start first, right? All right. A. Define the coefficient of surface tension. Right, that's a theory part, straight theory. Straight theory. So we know as an equation, F equals TL. Then T is given by FOL. T is given by FOL. Right. Basically, that is force acting in one direction per unit imaginary straight line, unit length of imaginary straight line. Right. And as the other keywords, you have to say that. The other keywords you have to say that at constant temperature. Right. Okay, write down this way. Write down this way. That's the definition. No? That's the definition. Write down. Force per, force per, force per, force per unit length of, force per unit length of, force per unit length of, force per unit length of imaginary straight line, imaginary straight line, or imaginary line is also enough. Imaginary line, imaginary line, imaginary line drawn on a liquid surface, drawn on a liquid surface, drawn on a liquid surface. At constant temperature, at constant temperature, at constant temperature, at constant temperature is defined as coefficient of surface tension, is defined as coefficient of surface tension. Right? That's it. B. Three long glass capillary tubes are vertically in different liquids having the angle of contact 0, 90, and 135, so that a half of the tube is inside the liquid. Draw a sketch showing the shape of the liquid meniscus inside the tube, the height of the liquid column, and the shape of the liquid surface outside near the tube for each case. Right. Then angle of contacts are 0, 90, and 135. Right. So in 0 case, we know, right, in 0 case, we know the liquid is going to be a wetting liquid if there is 0. So the liquid acts like this. Liquid acts like this. Right? If there is 0, it is going to act as a wetting liquid like this. Right? And if there is 90, right? If there is 90, right? There's no curvature if there is 90. Right? If there is 90, there's no curvature. There's no curvature. Right? Always when the liquid is a wetting liquid, it has a capillary rise. Huh? If the liquid is a contracting liquid, it has a capillary depression. Now that's why in the first one we have a capillary rise. And now in the second one, nothing. In the second one, nothing. Right? That is 90. And then for a case like 135, obtuse angles means they are contracting liquids like mercury. They are contracting liquids. Right? So this is how a contracting liquid behaves. This is how a contracting liquid behaves. 135. So these three cases are the three cases you are asked to draw, right? These are the three cases you are asked to draw. Then, see, derive an expression for the maximum radius Rm of a tiny solid sphere that can be floated without piercing the surface of a liquid with coefficient of surface tension T. The density of the material of the sphere is beta. Density of the material of the sphere, okay, beta, and it is greater than the density of the liquid. Assume that the contact angle between the material of sphere and liquid is 0. The volume of a sphere is given by 435 r cube. But about 435 r cube, we already know, no, right? Now, when it is in balance, this is what is happening, right? When this is in balance, now the sphere floats, right? The sphere floats, right? And when it floats, this is how the liquid behaves. This is how the liquid behaves. And the surface tension forces are all around this, right? Surface tension forces are all around this, like this. Surface tension forces are all around this, right? And let's say the resultant of all the surface tension forces, right, is F. And other than that, we have weight of this mg. Right now, if it floats, then write the equilibrium. If it floats, write the equilibrium. It floats, no? Then from the equilibrium, we can say vertical equilibrium F equals mg. Right? Surface tension force is written as TL. Surface tension is written as TL as a force. Then T into L. L is contact-in length. Right? Contact-in length is if the radius is Rm. Right? Contact-in length is 2 phi r. Then this is 2 phi Rm. Mg, M is 0. Right? M is 0. And volume is given 4/3 phi r cube. Right? 4/3 phi r cube. Then that r is Rm. Rm cube. Rho is given as beta. Right? G. Rho is given as beta. Then simplify this. Simplify this. Phi 2. Phi cancels 2 2. This 2 cancels 1 Rm 2. This cancels, it becomes squared. Right? And we are asked about the maximum radius. We need Rm. Okay, then subject Rm. Now this Rm squared is here. Right? Then Rm squared is 3D over 2 beta G. 2 beta G. Then we need Rm. Rm is given by square root of 3D over 2 beta G. Right? Rm is here. Rm is here. A simple force equilibrium. A simple force equilibrium. Right? D. Hayes test is done to detect the presence of bile salts in urine to identify patients having jaundice. Bile salts reduce the surface tension of urine. Sulfur powder having uniform spherical particles is sprinkled on a sample of urine taken for the Hayes test. Right, first one, using the expression derived in C. Above, calculate the maximum radius Rm of spherical sulfur particles that can be floated on normal urine. Density of sulfur is 2000 and the surface tension of normal urine is 6.5 times 10 to the minus 3. Give you an answer to one decimal place in millimeters. Right. Then we proved that Rm equals square root of 3D over 2bg, 2 beta g. Then 3, T is given 6.5 10 to the power minus 3 over 2 beta is density 2000, right, G. Then have to simplify, that's a simplification, a small simplification, right? And after the simplification, the final answer we get is this, right? Now, if this is simplified to root 47.75, right? 10 to the power minus 4. Now, root 47.75, no? 47.75. Then this is approximately 49 because we are asked only up to 1 millimeter decimal, right? Then we can approximate this to root 49 10 to the minus 4, right? Which means this is 7 times 10 to the minus 4 meters, no? Then Rm equals 0.7 millimeters. You are asked to keep the answer in millimeters. So that is 0.7 millimeters, right? 0.7 millimeters. 0.7 millimeters. Right. Then part 2. Sulfur particles will sink if bile salts are present and the person is identified as positive for jaundice. For Hayes test, according to the value calculated in D1, above sulfur particles of radius 0.9 Rm is used. If these particles just sink in the urine sample of patient, calculate the surface tension of affected urine. Okay, round off your answer to 1 decimal place in scientific notation. Okay, now there is 0.9 of Rm. No? There is 0.9 of Rm. Then we can use the equation again to solve the same. Then from this Rm equation, again we can subject T. No? If T is subjected, what's happening? If T is subjected as 2 beta G Rm squared over 3. No? Right? From the same. Then I need T. Right? I need T. Then 2 times beta is 2000 G Rm is 0.9 Rm. No? 0.9 Rm is 0.7 millimeters 10 to the minus 3 over 3. Right? Over 3. Right? Then simplify this. That is 5.3 times 10 to the power minus 3. And then minus 1. Now what has happened is, right? Now surface tension has decreased. In normal urine, it was 6.5 something, no? Right? In normal urine, it was 6.5 something. It was given at the beginning, first calculation. It is 6.5. Now it is 5.3. Right? Part A. If a capillary tube of radius 0.4 millimeters is vertically dipped in unaffected urine sample, right? So that is normal urine sample, calculate the capillary rise. Okay. So we know we have a proved equation for capillary rise, right? We have a proved equation for capillary rise, right? If this capillary rise is h, right? If the capillary rise is h, now angle of contact is given, right? Angle of contact is given. If angle of contact is given, right, for a capillary rise, we know that is given by h rho g equals 2t over r cos theta. 2t over r radius of tube, 2t over r cos theta. Right? This is the proved equation. Since we are not asked to prove the equation, you can use the equation at once. Huh? You can use the equation at once. That's totally fine. Totally fine. Density of normal urine is 1020. The angle of contact between urine and glass is 30. Give you a answer to the nearest integer in millimeters. Take root 3, 1.73. Right. So we have to find the capillary rise. Then H rho density of urine is 1020 into 10. Then 2T. Right. Then this is unaffected. It says if there is unaffected, T is 6.5 times 10 to the minus 3. No? Then cos theta is cos 30 now. Angle of contact is given as 30. Then cos 30, right? Cos 30 is root 3 over 2. Then root 3 over 2. And radius, if a capillary tube of radius 0.4, then radius of tube is 0.4 millimeters. 0.4 millimeters means 0.4 into 10 to the power minus 3, no? 0.4 times 10 to the power minus 3. Then we can write it as, right, 4 times 10 to the minus 4. Right? Okay. Now, from here, we have to do a simplification. Right? That's a small simplification. Then, by 2, this cancels. Then by 2, this is 5. Right? And right. Then if you simplify this h, right? Again, decimal is coming, right? Decimal is coming. That is 2.7 millimeters, right? 2.7 millimeters, right? Then F. Another test method can be designed using an electrical liquid spray gun producing tiny urine droplets with identical radii in 1 second. What will be the ratio of power needed for forming droplets from urine with a bile salt sample to the normal urine sample? Okay, assume that the densities of urine in both samples are same. Give you an answer to the to 2 decimal places. You answer to 2 decimal places. Right. So we know radii are same. No? If radii are same, they are droplets. Right. We know energy of a droplet is given by 4 pi r square t. No? Energy of a droplet is 4 pi r square t. And energy of a bubble is 8 pi r square t. Whereas energy of a droplet is 4 pi r square t. Right. Now, what we can say is if energies are equal, right? If energies are equal, powers should be equal, no? Because if we consider the same time period, same time interval, same time period, powers are also equal. Then to create power, right? To create power, if we divide both sides by t, see, to create power, if we divide both sides by t, now this side, the power is created. And the question is given as in 1 second, no? Then for the question, t equals 1 second. For this part, t equals 1 second. It is given as t equals 1 second. Right? That is clearly given as t equals 1 second. That is t equals 1 second. Right? Then E over T is power. Then power equals 4 phi r squared t, 4 phi r squared t, right, over 1, doesn't matter. Right? Now, since radius is common, we can say p proportional to t, no? Because all these terms are common now. 4 is a constant, 5 is a constant, radius is a constant. Then p is proportional to t. Now you can use this for these two scenarios given. Right? We can use this for the two scenarios given. Right? Then power required initially is say P1, right? P1 power required initially is proportional to initial surface tension, right? It is proportional to initial surface tension. Then P1 means another method can be designed. Right? Okay. Then give your answer, right? What will be the ratio of power needed for forming droplet? Okay. Then P1 and P2 are not introduced, right? So we can use as P1, P2, and finally we have to get the ratio, right? Finally we have to get the ratio, right? Then it was 5.3 10 to the power minus 3, no? Right? When that is affected, and if that is not affected, if the power is P2, right? If that is not affected, surface tension was 6.5 times 10 to the minus 3. Then divide these two. That's it. P1 over P2. Then P1 over P2 equals, that is 5.3 over 6.5, no? 5.3 over 6.5. That is 0.82. Then the ratio is asked. Ratio is 0.82. Ratio is 0.82. Right? First question is done. First question is done. Right? Now again, what I need to say is, if you are familiar with these theories properly, right? There's no way that you couldn't do this. Right? There's no way that you couldn't do this. Right? Now, when it comes to properties of matter question also, that is comparatively an easier question. Right? Comparatively an easier question. Right? But you should know all the theory parts to the best, because always these lessons are like connectable as well. Surface tension to viscosity, viscosity to elasticity, elasticity to surface tension. So likewise, they are very easily connectable. Right, next. 2023. 2023. 23 is from viscosity. Right, that is from viscosity. Let's see. Right, 23. As shown in the figure, a cylindrical syringe is attached to a cylindrical injection needle. which is used to inject a liquid medicine into a vein of a patient. Both the syringe and the needle are kept horizontally and completely filled with medicine. Completely filled with medicine. The internal radius of the syringe is R1 and the length between X and Y is L1. Everything is marked in the diagram. Huh? The internal radius of the needle is R2 and the length of the needle is L2. The coefficient of viscosity of the medicine is eta. When a force F is applied to the piston or the syringe, piston of the syringe, the rate of volume flow of the medicine through the system is Q. Rate of volume flow through the system. Right? So we know these two tubes are going to act as two tubes in series combination. In series combination, volume flow rates are equal. Right? In series combination, volume flow rates are equal. Right? In series combination, volume flow rates are equal. Right? Volume flow rates are equal. Volume flow rates are equal. Then it says Q. The NZ of the needle is inserted into N. Right. Part A. 1 second. Right. Part A. Part A. Write down the Poiseuille's equation for the rate of volume flow Q of a viscous liquid passing through a horizontal narrow tube. Identify each symbol in the equation. Right. Poiseuille's equation. So we know Poiseuille's equation is V over T equals phi delta P R to the power 4 over 8 T L. And this V over T is now given as Q. V over T is now given as Q. Then Q equals phi delta P R to the power 4 over 8 T L. Right. And you have to identify this. Right. It says identify each symbol. Identify each symbol. Then delta P pressure difference. Delta P pressure difference. Right. R radius of tube. R radius of tube. Then eta coefficient of viscosity. Coefficient of viscosity. And L length of tube. Right. And Q is already introduced here. Q is volume flow rate. Right. So that's a state theory. That's a state theory. Right. Part B. Write down an expression for the pressure P at point X due to applied force. Pressure P at point X. Right. Pressure P at point X due to applied force. Due to applied force. Sorry. Due to applied force in terms of F and R1. Assume that the force F is uniformly distributed over the cross-sectional area of the piston. Okay. Then that R is given as R. So we know, right, part B1, right? We know force is given by, right? Force is given by pressure into area, no? Right? Force is given by pressure into area. Or else pressure is given by force over perpendicular area. Then pressure equals force, right? Force that was given as F. Then over perpendicular area, radius is given as R1, then the perpendicular area is phi R1 squared, phi R squared, no, phi R1 squared. Then the pressure on that surface is this F over phi R1 squared. Second one, if the atmospheric pressure is P naught, what is the total pressure? P1 at point X. Okay. P1 at point X. P1 at point X. Okay. Point X is inside. Point X is inside. Then we know if the atmospheric pressure also acts, total pressure is given by, right? Total pressure. Total pressure. What is total pressure? P1. Is it P1? Okay, it is P1. Then P1 equals atmospheric pressure is P naught, no? Right? Then atmospheric pressure is P naught. And pressure at here is P. Then P1 is given by atmospheric pressure plus P, that is 5 over, F over 5R1 squared. Total pressure. Because total pressure is due to the pressure exerts when you push and atmospheric pressure. That is due to pressure exerts when we push and atmospheric pressure. Right? Then, third one. If the pressure at point Y is P2, point Y, where's point Y? Okay, here. This pressure is given as P2. Right? This pressure is given as P2. Y is P2, write down an expression for P0 minus P2 in terms of Q, R1, L1, eta and F. Okay. P0 minus P2, okay. That is the pressure difference across that, no? That is the pressure difference across the tube, right? That is the pressure difference across the tube, right? Then, if the pressure difference across the tube is known, right, and check the letters, check the terms you are given to have. You are given to have QR1, right? QR1, L1. Then you are asked to apply Poisson's equation. Then first we can apply it for XY, for tube XY. For XY. Right, now we have to apply. Q is given as Q. Right? Then phi delta V. Pressure difference is now my tube is XY. Right? And always liquid flows from P to high pressure to low pressure. Right? Liquid flows from V to P to high pressure to low pressure. Then high pressure is P, no? Then P minus P2. Then pressure difference P minus P2. Phi delta P. R to the power of who? R is given as R1 in terms of Q R1, yeah. Then R1 to the power of 4 over 8 eta L1. 8 eta L1. Now, we have something we have found already for P and P2, right? We have something we have found already for P actually, for P. Now, what you are asked to write is P0 minus P2. P0 minus P2. Then, if we write P here, right? If we write P here, P means that is actually P1, P1 yeah, P1, total pressure is P1. Then P1 minus P2. Plug this. Q equals 5 over 80 del, 5 over 80 del, R1 to the power 4. Right, and here P1, for P1 we can write P0 plus F over 5R1 squared. Right? For that we can write P0 plus, one second. Right, P0 plus P1, P0 plus F4 5R1 squared minus P2, right? Minus P2. Now what we need is P0 minus P2, no? P0 minus P2 is here. Then that's a matter of subject in this. Then let's simplify and subject, right? Subject, right? Let's simplify this and subject. Right. Let's simplify this and subject. Then 8Q eta L over 5R1 to the power 4 equals P0 minus P2 plus F over 5R1 squared. F over 5R1 squared. Right, now we need P0 minus P2. Then P0 minus P2 is 8Q eta L over 5R1 to the power 4. 5R1 to the power 4 minus this part F over 5R1 squared. Right? Final answer. Right? Have to simplify and keep it like this. P0 minus P2. Right? So likewise, Go along the guide of the questions given. Right? You are guiding towards something, no? You are guided. You are guided towards something. You are guided towards something. Right. Then 5. Sorry, 4, right? 4, 4. अभी मैं करे 3. Yeah. Then 4. 4. If the pressure at point Z inside the vein is P3, pressure at point Z inside the vein is P3, right? This point is P3, is P3. Where is it? Right, if the pressure at point Z inside the vein is P3, write down an expression for P2 minus P3 in terms of QR2, L2 and eta. QR2, L2 and eta. Right, now, if I need P2 minus P3, right, if I need P2 minus P3, then what we can do first is, we can use Poisson's equation again for the second tube, no? Main tube better than for YC. For YC. For YC. Right? Poisson's equation again. Then we know Q is given by, right, phi delta P. Now delta P there is P2 minus P3, no? Pressure difference, phi delta P, R to the power 4, R is R2, then R to the power 4 over 8 eta, L is L2. Right, we need P2 minus P3, then just subject this. Then P2 minus P3 equals 8Q eta L2. 8Q eta L2 over R2 to the power 4. Right? Sorry, 5, you know. Then 5. 5 R2 to the power 4. Right? 8Q eta L2 over 5 R2 to the power 4. Right? Now P2 minus P3 was asked, and P2 minus P3 is here. Right? Now P2 minus P3 is also known. Right? Then, next. Using the expressions written in B3 and B4 above, write down an expression for P0 minus P3. Say you are guided. See, you are guided gradually to the final target. Right? Then, expression for P0 minus P3 in terms of, okay, P0 minus P3. P0 minus P3. Now, in the first equation, I have P0 minus P2. Second one, P2 minus P3. Then, if these two are added, that is coming, no? Since we are going to add, let me label this as equation 1. And let's label this as equation 2. Then, simply, we can add those. 5. Then, 1 plus 2. 1 plus 2. Then, P2 is going to cancel, and P0 minus P3 comes. P0 minus P3 comes here, right? Then from the first equation, 8Q eta L over 5R1 to the power 4. 8Q eta L1 over 5R1 to the power 4. Right? L1 actually. Minus F over 5R1 squared. Minus F over 5R1 squared. Right? Plus P3 8Q eta L2 eta L2 over 5R2 squared. Right? 5R2 squared. Then no need to simplify using the expressions written. Okay, write down an expression. That's an expression, no? Otherwise, there are common terms. But no need to take out even. That is enough. This is enough. That's enough. 6. Hence, write down an expression for f in terms of q r1. Okay. Then if I need q, subject q from this. If you need f ne, write down an expression for f. Then if you need f, subject f from this. Subject f. Right. Then f is here. P0 minus P3. P0 minus P3. right? Then you can switch the sides, right? Switch the sides. When sides are switched, then while sides are switched, we can take this out also. 8q eta is common. 8q eta or 5 is common. Then here L1 over R1 to the power 4, right? Minus L2 over minus L2 over R2 to the power 4, right? We need to subject F, no? Then this is F over 5R1 squared. F over 5R1 squared, right? Now, if all the terms are multiplied by this 5R1 squared, this is done, no? If all the terms are multiplied with or multiplied by this 5R1 squared, it is done. Then to subject F, then 5R1 squared, here P0 minus P3 remains, minus here 5 to 5 cancels, then 8q eta R1 squared remains with this part L1 over R1 to the power 4 minus L2 over R2 to the power 4, R2 to the power 4, right? That's it now, because hence write down expression for F in terms of right. That's done. F එකට ලියන්න කියලා කිව්වේ F එකත් හරි. Right? Then C, part C. The pressure P3 in the vein is 10 millimeter Hg, right? Hydrogen millimeters, 10 millimeter G, higher than the atmospheric pressure. First one, determine P3 minus P0 in pascals. Density of mercury is 1.36. Density of mercury is 1.36. Okay, now P3 minus P0 is the total pressure difference across this, no? Right? That is the total pressure difference. Total pressure difference. And what it says is the pressure is, that is 10 millimeters higher than atmospheric pressure. 10 millimeters higher than this. Right? If that is 10 millimeters higher than this, 10 millimeters, no, just 10 millimeters, then we need to find this P3 minus P0. Then there is 10 H rho G, then 10 millimeters, 10 to the minus 3. Rho is 1.36. 1.36. Where is it? 10 to the power 4. 1.36, 10 to the power 4. 1.36, 10 to the power 4. Right? Then G. If this is simplified, the pressure is coming. Then 10 to the power minus 3 to this cancels. Minus 3 to this cancels. Then 3 with 3. 100 remains, 1000 remains. Then 1.36 into 1000 means 1360. That is in pascals. 1360 pascals. That is in pascals. That's a pressure difference. Right? We did everything with the SI unit. So that is in pascals. Right? Second. If R1 equals 2.5, L1 equals 50, R2 10, L2 60, and eta 2 times 10 to the minus 3 Pascal seconds, determine the magnitude of the force needed to inject the volume flow rate of 3 times 10 to the minus 7 liquid medicine into the vein. Take 5 equals 3. Hint the determination of F. Two terms having small values can be neglected. Okay. Two terms having small values can be neglected. Right. Then before going to the equation, check these terms. Right? If they are small values, we can neglect, no? If they are small values, we can neglect. Then about first term, we know 5R1 squared P0 minus PB, no? First term is 5R1 squared, right? Where's it? Right. Then from the equation, P naught minus PB, first term, P naught minus PB, phi is 3 and R1 was given 2.5 millimeters, then 2.5 10 to the minus 3, right? 10 to the minus 3, then we read right, force needed. Force එක වාගන්ති. Force එක වාගන්ති ඉන්නේ. Then to check the neglectable or negligible terms, right? Negligible terms එකක් තියෙනවා කියලා කියනවනේ. Right. Clearly says that small terms are negligible. Then to neglect or to consider, we have to get an idea about what is coming from here. We have to get an idea about what is coming from here, right? What is coming from here. Then this part, phi R1, this thing, P naught minus PB, then for P naught minus PB, that is the pressure difference, no? That we found before as 1360. That we found before as 1360. Right? Then that value is coming as 2.55 10 to the minus 2. Right? That value is coming as 2.55 10 to the minus 2. This is one value. And the other term is 8 cube e R1 squared L1 over R1 to the power 4, no? Right? L1 over R1 to the power 4. Now, since this is subtraction, checking L1 over R1 to the power 4 and L2 over R2 to the power 4 is enough. Right? That is also enough. Because you can get an idea whether what is going to be removed. Then first term, L1 over R1 to the power 4. L1 over R1 to the power 4. What about L1? L1 50. Right? R1 to the power 4. R1 was 2.5 millimeters. Then 2.5, right? Milli means 10 to the minus 3. Then to the power 4. Right? R1 to the power 4. Then what is coming? 2.5 times 5 කියලා කියන්නේ ඒක 2 නේ. ඒ කියන්නේ 50 වල 20. 20 times 4 is 80. Then this is 8 times 10 to the power 3. Only ළඟට ආවම. And the next term is L2 over R2 to the power 4. L2 over R2 to the power 4. Now L2 is given as 60. Right? R2 is given as 0.1 millimeters. Then 0.1 can be written as, without writing it as 0.1, let me write it as 0.1 millimeters, no? 0.1 millimeters, no? Yeah, that is 0.1 millimeters. Then 1 times 10 to the minus 4. 1 times 10 to the minus 4, right? To the power 4. And if you check that value, now here actually 1 is missing. This is 10 to the minus 2 given in centimeters, no? Yeah, this is also given in centimeters, 10 to the minus 2. 10 to the minus 2. Right. Then simplify. If this is simplified, 3.75 is coming. 3.75 10 to the power 9 is coming. 3.75 10 to the power 9 is coming. Then what can we neglect? Right? What can we neglect? This is a 10 to the power 9. Then this was our ultimate target. Find in negligible ones. This is neglected. Right? And first one. Sorry, first එක හරිනේ. This is considerable. Right? Then about this, it was 8.3 neglected. Right? It asked us to right? It asks us to neglect the unwanted term, no? Sorry, neglect the small terms, no? Right? Hint at the dibba. Till in the determination of f, two terms having small values can be neglected. Two terms having small values, then these two are neglected. Only this is selected. Only this is selected to go ahead. Right? Only that is selected to go ahead. Then, if the other two terms are neglected, f is given by. If the other two terms are neglected, f is given alone by this term remaining here. Right? Which one? L2 over R2 to the power 4. Then from that, what is coming is this. Make I multiply with only 8q e to R1 squared. Right? Then f is minus minus becomes plus. Then 8q e to R1 squared. 8q e to R1 squared. Then times L2 over R2 to the power 4 times L2, right? Then R1 to the power 4. R1, then L2 over R2 to the power 4. L2 over R2 to the power 4. Okay. Right, then this is simplification. Right, these are sorry, R2 में these are simplification. Now simplify. Then 8, right? Q was what Q? Volume flow rate 3 times 10 to the minus 7. No? 3 times 10 to the minus 7. Given 3 times 10 to the minus 7. 8Q. Then eta was given 2 times 10 to the minus 3. Right, R1 to the power 4. R1 is 2.5 millimeters. Then that is 2.5 squared 10 to the minus 6. Right, over R2 to the power 4. R2 was 0.1 millimeters. Then 1 times 10 to the minus 4 to the power 4. Right. I have to do a small simplification. And this is exactly simplified. This is exactly simplified to 18. It is exactly simplified to 18. Right? That is simplified to 18. 18. Right? That's kind of a good part. It's kind of a good part. Then can be neglected. Okay. Part 3. Now always you have to be with the flow, right? What is the flow speed of liquid medication inside the needle? Take 5 equals 3. Right. So we know if we need speed, we can write speed using V over T. Volume flow rate can be written as AU, right? Fluid dynamics, volume flow rate can be written as AU. Now the volume flow rate is given as Q, then Q is AU. Then volume flow rate was given 3 times 10 to the minus 7, 3 times 10 to the minus 7. Right, area is 5. Right, now it is going out. It is going out from R2, then 5 R2 square. Then R2 was 0.1. No? Then 5 R2 squared. 5 is here. R2 is 0.1 over 0.1 10 to the minus 3 and 1 times 10 to the minus 4. Right? Squared. 5R squared U. Then U is given by, right? U is given by 3 to 3 cancels. U is given by, right? Now here this 10 to the minus 8, this is minus 7, then only 10 to the 1 remains. So that is exactly simplified to 10 ms minus 1. Right, that is 10 ms minus 1. 10 ms minus 1. Right. Part D. Part D. In a modern jet injection method, needle-free liquid medicine is delivered into the body using a high-pressure nozzle, just touching the skin. A narrow stream of liquid medicine penetrates the skin and delivers the medicine into the tissue. The inner radius of the opening of the nozzle is 4 micrometers. Okay, now that is even smaller. When uh, when the liquid medicine is filled in the horizontal syringe, the liquid starts to release from the operating of from the opening of the nozzle at a certain pressure. Okay, first one. Write down an expression for the excess pressure delta V across the spherical meniscus of radius r. Okay, then that's a proved equation. Delta V equals 2d over r. Delta V equals 2d over r. Right. Second one. Calculate the pressure P dash needed to be in the liquid medicine near the nozzle when the liquid drop is just detached from the opening of the nozzle. Just detached from the opening of the nozzle. Surface tension of the liquid medicine is 8 times 10 to the minus 2 and atmospheric pressure is 1 times 10 to the 5. Right. Then delta V can be written as, if this pressure is P dash, then P dash minus atmospheric pressure, P naught. Right, equals 2d over R. Then P dash is what we need. Right, P naught is 1 times 10 to the power 5, that is 10 to the power 5. 2. T, tension, surface tension. Surface tension is 8 times 10 to the minus 2. 8 times 10 to the minus 2. Right, over R. R is in 4 micrometers, that is micrometers. Right, 4 micrometers. Then micro to SI 10 to the minus 6. Micro to SI 10 to the minus 6. Right, simplify. Simplify. Then this is 4 times 2. 4 times 2. Right, 4 times 2. Then 10 to the power 5 plus what remains here is what is remaining? 2 to 4 is there. Then 4 times, that is 4 times 10 to the power minus 6 minus 2 means 10 to the power 4. 10 to the power 4. Then we can write it using 10 to the power 5 as, right, 10 to the power 5 as, that is 0.4 times 10 to the power 5, no? 0.4 times 10 to the power 5. Then this one here with this 10 to the power 5 and that is added up, then 1 plus 1.4. Right? Sorry, 1 plus 0.4. 1 plus 0.4. 1 plus 0.4. 1 plus 0.4 times 10 to the power, right? 10 to the power 5. Then this P dash equals 1.4 10 to the power 5 pascals. 1.4 10 to the power 5 pascals. Right? That's a special part, a special question, right? From viscosity, right? A special question from viscosity. All right. Right. 2 questions are done so far. 2 questions are done so far. Right. Give me 2 minutes. Give me 2 minutes. Right. Until then, take it down. All right. Right. So that's the end of question 2 also. That's the end of question 2. Right. End of question 2. Right. Then next. Sorry. #21. Sorry. So before 21, we'll do another surface tension question. Before 21, let's do another surface tension question. Go to 17. 17. Right. That's a different surface tension question. Right. A little bit different surface tension question. A little bit different surface tension question. 2017. 2017. Right. Okay. Let's see. Right. Let's see. Passage type question has come that year. Right. And one more second. There are some urgent messages to be replied. Oh, no, that's fine. No, that's fine. One second. Okay. Let's go to the next one. 17. 17. Right. Read the following passage and answer the questions. Right. So if that's a long passage, see, that's a long passage. That's a long passage. Now don't read the passage from the beginning to the end first. Right. Don't read the passage from the beginning to the end first. Right. Go to the questions first. Go to the questions first. And then you can go through you can skim through the passage. Right. The passage questions are passage right. That is not going to work out that way, because then you will run out of time. Right. You will run out of time in that case. So therefore, go to the questions first. Go to the questions and searching for the answers for the questions, skim through the passage. Right, skim through the passage. Then both will happen at the same time. Both will happen at the same time means you are going through the passage while finding an answer. You are going through the passage while finding an answer. Otherwise, you are not just reading out the passage. Then go to the questions and then go through the passage. Right? While extracting the answers. First one, name 3 fundamental physics concepts which can be used to explain some aspect of the stability of soil and sand. Okay. 2017. Okay. See, name 3 fundamental physics concepts. Explain the aspect of. Okay. Then, searching for those, go through the passage. See, fundamental physics concepts such as gravity, friction, and surface tension. Right. So that's gravity, friction, and surface tension. Then first one, gravity, friction, gravity, friction, and surface tension. Gravity, friction, and surface tension. Right. Then next one is actually A. This is actually A, part A, right? Yeah. This is A. Then B, write down 3 main mineral constituents of soil. Right. Write down 3 main mineral constituents of soil. Right. Go through the passage again. Right. Everything passage again. You have to find them from the passage. Right. Where is it? Soil heavy gradually in sand. Soil is generally a porous medium covers in mixture of mineral particles such as, right, maybe clay, silt, and sand. Clay, silt, and sand. Clay, silt, and sand. Right, නිකම් මේක go through කරන්න. Then ඔයාලට හම්බුයි. Clay, clay, silt, and sand. Clay, silt, and sand. Clay, silt, and sand. Clay, silt, and sand. Right. Then next one. Next one. C. See, in a road construction, soil has been removed from a certain section of the slope, altering the natural slope as shown in the figure 3. Right. This is a vulnerable place for landslides. Explain this using the information given in the passage. Okay. So in the passage, you are given about here angle of free pose, no? Right? You are given about angle of free pose. Right? Increasing the angle of repose, see this line. Increasing the angle of repose can create instability on the slope. Right? Now, in this case, what happens is, see, now it says angle of repose is alpha. Now, for this angle of repose alpha, that is stable. But if angle of repose is increased, that is going to be unstable. If angle of repose is increased, that is going to be unstable. Now, in this cut, see what has happened. Now, about this side, this angle of repose is greater than the angle of repose given there. Right? Then when angle of repose increases, what happens is, right? When angle of repose increases, what happens is, then the instability, right? Instability increases. Right? That's the idea. Then what you need to explain? This is vulnerable place for landsides. Explain using, okay. Then write this way. Since angle of repose. Now this angle of repose thing is coming from the passage. Since angle of repose is higher than the supposed value, right? Higher than the supposed value, it becomes unstable. And vulnerable for landslides. Right? And the main keyword here is this angle of repose. And you have to say that it is higher than the supposed value, right? Those are the main keywords. Right? Very important. Because they are coming from passage. Passage use කරලා explain කරන්න. That is clearly given to you to use the passage. Right? Clearly instructed to use the passage. Okay, then part D. Addition of water into dry sand dramatically increases the stability of sand. Explain the main reason for this. Right? When water is added, what happens is, that is given in the passage. When water is added, the adhesive forces between soil and water increases. Right? The adhesive force between soil and water increases. Right? Voids filled with either air or water as shown in figure. The right leaning examples are the parameters. Make a water ගැන තියෙන කොහොමද කියලා බලන්න. Right? Now, from our knowledge, we know adding water means adhesive force increases. But check whether if there's something else given in the passage. dramatically increase the attraction between grains. It is due to the adhesive forces associated with the water bridges between grains. Answer. Right? Then explain this way. Adhesive force is a keyword now. Adhesive force is a keyword. Right? Then addition of water, explain the main reason for this. Increasing adhesive force between water and grains. Increasing adhesive force between water and grains. Increasing adhesive force between water and grains. Explain the main reason for this. Increasing adhesive force between, adhesive force is a keyword, adhesive force between water and grains results in higher stability, right? Results in higher stability or higher stability of sand, higher stability of sand. Right. So still we are stick to the passage. Still we are stick to the passage. We were finding those things from the passage. We were finding all the answers from the passage. Right. E. A water bridge between two spherical sand grains is shown in figure 4. Copy the figure 4 to your answer script and draw the resultant reaction forces using arrows on each grain due to surface tension. Right. I have to copy this down. Right. Then this is how the water layer here is. Right. This is how the water layer is. Right. This is how the water layer is. So we know the adhesive forces are acting on the contacting points. No, adhesive forces are acting on the contacting points open to atmosphere. Then here we have one adhesive force. Then similarly here again, and here. Right? These are the forces. These are the contact points open to air. These are the contact points open to air. Right? Then you do surface tension. Then F. Consider the water bridge formed by two sand grains shown in figure 1b, where the radii of curvature of the upper and lower menisci are R1 and R2 respectively. Right? Diagram like this. Right? Figure B. Like this. Lower meniscus and upper meniscus. Then it is like this. B, A, and the height is given as H. Okay. Then 1b, where the radii of curvature of the upper and lower menisci are R1 and R2 respectively, using the expressions for the pressure difference across the upper and lower air-water interfaces. Derive an expression for the height h of water column in figure 1b. Take surface tension and density of water as T and D respectively. Assume that the pressures at points A and B shown in the figure are equal. Okay. Pressures at A and B are equal. Then we know pressure difference through a liquid meniscus is given by 2TOR. No? Pressure difference through a liquid meniscus is given by 2TOR. Right. Now let's assume pressure inside this meniscus as P1 and pressure inside this, outside this as P2. Right. Then we know pressure difference through the first meniscus can be written as always inside is greater than outside. Right. Then let's assume PA equals PB equals P for our is. Then for the outside I can write, for the pressure difference I can write P minus P1. Equals, that is 2D over R1, equation 1. Right, from the upper meniscus. Similarly, from the lower meniscus, right? From the lower meniscus, we can write inside this again P, no? Inside this again P. Again P. Then P minus P2 equals 2D over R2 equation 2, right? About P1 and P2. About P1 and P2 we know, right? We can write using hydrostatics P1 plus H rho G, right? Rho is given as D, right? Yeah. Then P1 plus HDG is P2, right? Which means we have P2 minus P1 here as HDG. Then it says P2 minus P1 equals HDG, that is equation 3. That is equation 3. Right now, you will be able to see now, if 1 and 2 are subtracted, we can create P cancels and we can create 1 and 2 are subtracted. P2 minus P1. Then for that, we can plug HDG. Then 1 minus 2. 1 minus 2. Right? 1 minus 2 gives P cancels. 1 minus 2. Then minus P1 plus P2. Then that is directly P2 minus P1. P2 minus P1. Then left hand sides are done, right hand sides 2T over R1 minus 2T over R2. Then 2T over R1 minus 2T over R2. 2T over R1 minus 2T over R2. Then for this we have an answer as HDG. HDG equals 2T is common. Then 1 over R1 plus, sorry, minus 1 over R1 minus 1 over R2. Now, what's the answer? What is asked? There are an expression for the height h of photo column. Okay, we need h, no? Then subject h. That is done. H is then 2t over dg brackets 2t over dg brackets 1 over r1 minus 1 over r2. 1 over r1 minus 1 over r2. Right? So without writing equations this way, right? There's another method you could do this. There's another method you could do this. You can start from the known point and write pressures up until you reach another known point. Now A and B are known points, no? Then you can start writing pressures at A and you can finish writing pressures at B. Right? That's also fine. Right? මෙහෙම ලියාගෙන ඉන්නත් පුළුවන්. Alternative method. See? Alternative method. Alternative method. Starting from A, that is P, no? Then here you are jumping out. Jumping out means minus 2T over R1. Minus 2T over R1. Going down through the liquid. Then plus H, D, G. And jumping into the meniscus. Plus 2T over R2. Now we add P again. Hurry, never make lazy. P to P cancels. Then HDG equals අර වගේ equations ගොඩක් simplify කරගෙන ඉන්න දෙයක්වත් නෑ. 2T is common. 1 over R1 minus 1 over R2. Then we need H. H is 2T over dg 1 over R1 minus 1 over R2. Right? Any method is fine. Any method is fine. Next. G. Calculate the height h for situation mentioned in F above. Take R1 equals, okay, values are given. Then h equals, right, 2. T, what about T? 7.2 10 to the power minus 2. 7.2 10 to the power minus 2. Over dg. D 10 to the power 3. 10. Then 1 over R1 is 0.8. Then 0.8 millimeters 10 to the power minus 3. 10 to the power minus 3 minus 1 over R2 1 millimeter 1 times 10 to the power minus 3. Right? Again, simplification. Right? A small simplification. Right, then here 2 times 7.2. that is 14.4 no. 10 to the power 4 කියලා කියන්නේ -6 altogether, right? 10 to the power -6 altogether. 10 to the power 3, 10 to the power 4, then -6. And here 10 to the power 3 is common, no? Right? 10 to the power 3 is common. That is the 10 to the power 3 at the top, that is common. Then take it out. 10 to the power 3 is common, take it out. Then inside 10.8, 10.8, 10.8, 10.8 means we know it is 0.8 is 8 over 10, no? Then 10 over 8, again 1.25. That is 1.25 minus 1. 1.25 minus 1, then 0.25. Then finally, simplify this, right? 360 comes, then 3.6 times 10 to the power minus 3 meters, right? Which means that is 3.6 millimeters. 3.6 millimeters. 3.6 millimeters. Right? 3.6 millimeters. Next. H. Consider a situation where the pressures at points A and B are higher than the situation shown in the figure 1b. Copy the figure 1b, including the two menisci, to your answer script and draw the shapes of the two new menisci and clearly label them as X and Y. Okay. Now, what it says is pressures at A and B are higher. Right. Then we have to argue on the change. You have to argue on the change. What's happening here? You have to argue on that change. How to argue on the change? We know delta P is given by 2 TOR for a meniscus. Delta P is given by 2 TOR for a meniscus. 2 TOR. Right. Now we know delta P is pressure inside minus pressure outside the meniscus equals 2 TOR. Now both A and B are pressures inside the meniscus. No? See, both A and B are pressures inside the meniscus. Then when pressure inside meniscus increases, which means when Pi increases, see what happens. When Pi increases, pressure difference increases. When pressure difference increases, now 2T part is a constant part. If it increases, R decreases. Then R decreases. Now the ultimate ultimate impact here is radius is going to decrease. Radius decreases. Right? Radius decreases. Now you have to draw this again with a decreased gradient, with a decreased radius. Right? You have to draw this again with a decreased radius. Simply මේ වැන් ආගිව් කරලා වැඩේ යන්න ඕනේ. Then this is what is given. Say these are the given meniscus. These are the given menisci. Like this, the given ones. And the new ones are with decreased radii. Decreased radii means the curvature becomes right more curved, like this. Curvature is more curved. Then X and Y, right? It becomes more curved because radius decreases. So likewise, without arguing, we can't say anything. Without arguing, you can't say anything. Argue kalla මොකද වෙන්නේ කියලා බලන්න ඕනේ. Right. 1 second. Right. Next. Next. X and Y. Okay. Then part I. Part I. If the pressures at points A and B shown in figure 1b are continuously increasing what will happen to the radii of the menisci if the pressures at points A and B shown in figure 1B continuously increasing, right? That is going to continuously increase. Okay. What is happened to the radii of the menisci? Contact angle and the resultant reaction. Okay. Menisci, radii of the menisci, contact angle and resultant reaction. And resultant reaction. Forces due to surface tension forces between the grains. Explain your answer. Okay. Now, first thing is you have to check with the radius. No, that is same. Now, as I mentioned before, pressure inside minus pressure outside is 2 TOR. Now, if this is continuously increased, right, same impact. No, if pressure inside is continuously increasing, then R is continuously decreasing. Then about radii of meniscus, right? Radius of meniscus. Then we can say radii of menisci decreases, right? Radius of menisci decreases, right? Radius of menisci decreases. Likewise, you have to argue. Then angle of contact. Angle of contact. What about angle of contact? When radius decreases, angle between the liquid and the wall, right? Now, when radius decreases, see, when radius decreases, see, this is what is happening. This is what is happening when radius decreases. Then always the angle between, right? Always the angle between the liquid and the tangent drawn to the meniscus, right? This one, see, this is decreasing now. This is decreasing, which means now angle of contact decreases and the minimum value of angle of contact that it could take is 0. Right? Minimum value of angle of contact that it could take is 0. So it is going to decrease up until 0. Then for this part also we can add it if needed. Radii of meniscus decreases until it's equal to until it is equal to radius of tube. 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 Radii of menisci decreases until it is equal to radius of tube. Okay, then angle of contact also decreases and the minimum value it could take is 0. Yeah, minimum value it could take is 0. Then angle of contact decreases. Angle of contact decreases up to 0. Angle of contact decreases up to 0. Angle of contact decreases up to 0. Right? Then finally, uh, resultant reaction. Resultant reaction. Resultant reaction due to surface tension. Then what happens is resultant reaction is also becoming 0. No resultant reaction. No resultant reaction. Angle of contact decreases, right? And radius decreases. And finally, the resultant reaction decreases to 0. Right? Resultant reaction decreases to 0. It decreases to 0. Resultant reaction also decreases to 0. Right? Then J, last part, J. Write down 2 human activities mentioned in the passage which can increase the likelihood of landslides. Right. Again, that is something from passage. That is something from passage. Right. Passage increase of weight of the soil making ideal situation for landslides. Capillary Yes, and the increase of weight of the soil making the ideal situation landslide, damage on the earth's soil surface due to the addition of large amounts of pesticides and fertilizers. Maybe. Then one is addition of addition of large amount of large amounts of large amounts of pesticides pesticides and fertilizers fertilizers, right? What else? Decrease the surface tension force between the grains and dramatically increase the likelihood of landslides. Okay. uh what else are given during rainy season? The soil saturated with the water. Okay. Quickly go through the passage and check if there's anything else given, right? That we can match this. See, right? One of the Tagawa. Right. May I create practical problems such as sinking heavy structures on ground. This, of course, due to compression of voids caused by the heavy loads on the ground, leaning of this rubber, right? Another important parameter which determines the stability. Okay. Check the human activities. Now the sum is finished. Sum is finished, right? This is something from the passage again. No? Sum is finished. Now here we have adding more water to addition of more water to soil can decrease friction and strength, right? Then addition of more water, right? Any two, addition of more water to soil, right? Addition of more water to soil and improper improper removal of about that it was given in the passage, no? Soil at slopes, right? And what else? What else? And road constructions, road constructions, road constructions in especially in mountainous areas, mountainous areas without a proper study, without a proper study, right? So likewise, some facts are given, right? Likewise, some facts are there, right? Again, young passage organ. That's it, right? Any questions? Now we have come to the end of the third question also. Right. Okay. Since we need to wind up the session before 12, right? Since we need to wind up the session before 12, uh, I'll be stopping the session here, and there are a few more other things to be shared with you, right? Then I'm going to use the time remaining to share the rest of the stuff that I need to share, right, before the exam, because it's the last day that you are meeting, right? So simply, now we have come to the end, right? You have come to the end of this whole journey, right? This is the complete end of the whole journey. We have been here for more than 2 years, right? That is actually 2 years and 2 months. That is 2 years and 2 months, right? And in general, about A levels, right? A level is the most competitive exam that you will ever get in your life, right? Because university exams are, I don't say they are easy, they are actually difficult. They are much harder than A levels. But the thing is, they are not as competitive as A levels, right? They are not as competitive as A levels. They are not as competitive as A levels, and they are, even though the content is difficult, right? Easily we can go through those exams, because when it comes to university exams, they are coming from only a content of a semester. Semester is only 14 weeks, right? Semester is only 14 weeks. Then easily we can go through them. But when it comes to A levels, right? A levels is the prominent and the most competitive, right, milestone we all have in your lifetime. That's once in a lifetime thing, and that's going to change your life upside down, right? There are numerous examples of such things, of such cases, like the people who have changed their lives upside down, right, after A level results, right? So therefore, this competition is not artificial. That is not artificially made. That is a natural competition because of the opportunities that you are going to open after A levels, right? So there are multiple opportunities, right? Right? There are plenty of opportunities. That's the thing, right? So therefore, A level is one of the milestones in your life, but that doesn't mean uh, if you didn't do better, or if you didn't do to your expected level at A levels, that doesn't mean that you are going to fail in your life. There are many other ways, many other different ways that you can go through. You can survive in the life, and you can succeed in the life, right? A levels නැති වුණා කියලා එහෙම වෙන්නේ නැහැ හැමෝටම. But once we have A levels, it makes more and more easier to you to proceed in your life. That's the thing, right? It makes more and more easier to proceed in the life, right? It makes very easier, right, to proceed in our life. That's the thing, right? That's the thing. So that's why the competition is made. Okay, then now we are in a situation where you are 5 days from the exam, right? Now we are almost on Wednesday, right? Now we have Wednesday, Thursday, Friday, Saturday, and Sunday. We are 5 days from the exam, right? 5 days from the exam. So plan all 5 days, and especially the days that you are spending in between the exam, right? The days you are spending in between the exam also, right? Plan it to the fullest. Plan it to the fullest, right? And uh, the other thing is, if you have say some parts that you need to refer continuously, maybe some parts in structured essays about physics. If you are doing chemistry, maybe inorganic parts, right? Sometimes organic parts, or environmental chemistry, right? Industrial chemistry. So likewise, if you need uh, to refer those things continuously, right? Such parts, right? Allocate sometimes in these 5 days, and when the exam is ongoing also, because now you are going to have your chemistry first paper on 19th, right? And you are starting the exam on 10th. So there's kind of a gap remains. If you stop, say you are stopping your regular work by this Friday 7th, right? You are stopping your work by this regular work by this Friday, right? එහෙම වෙන්නේ ගොඩක් වෙලාවට weekend එකේ ආයි physics, chemistry, or ICT බලන්න යන්නේ. When you have maths or bio on Monday, right? So ඉතින් chemistry කියන එක 7th වගේ වෙද්දි අතාරිනවා. ඒ නිසා ඉතින් පොඩ්ඩක් ඒ දේවල් පොඩ්ඩක් plan කරගන්න, right? And I gave a plan on the class in the class also. ඒ වගේ plans වලට ඔයගොල්ලෝ කැමති නම් ඒකට ඒ plan එක follow කරන්න. එහෙම නැත්නම් ඔයාලට plan එකක් හදාගන්න. Right? Have a small plan. Otherwise, don't go to the exam without a plan. Right? That's a point. That's my point. Don't go to the exam without a plan. Right? Plan එකක් නැතුව යන්න එපා. හැම වෙලේම අපිට plan එකක් තියෙනවා. Always we should have a plan. The way that you spend the exam in between. Right? In between days. ඒ days ටික යනවා තේරෙන්නේම නැහැ. Right? ඒක නිකම්ම යනවා. Right? When you start exam on 10th, right? Just after 12 days, all main 3 subjects are over. No? Just 12 days. Just 12 days. And you are done. You are done. Your story is done. Right? Your story is written. Right? Simple as that. Your story is written. Simple as that. Right? So plan your work. And in terms of physics, especially, right? In terms of physics, we have done plenty of things in the class, right? And we finished the theory class syllabus. Theory class means we finished the syllabus 6 weeks before the exam. 6 weeks means 1.5 months before the exam. We finished the theory parts, and that is one thing. And then we had a reverse class, right? We had a reverse class. So in the reverse class, I covered all the easier and important lessons at the beginning of this year, right? I started the reverse class in January, and in January we covered, just recall what we have done. In January, you have covered, we started with properties of matter, and in February, matter and radiation, right? Then March, electricity, right? Then electronics. So likewise, we went on, right? So the easier lessons are covered well in advance in the reverse class. And once that is covered in the reverse class, I put all questions in the paper class. So you practice writing questions from such, and I discuss those ones in the discussions, right? And about the paper class, you have written 20 papers, right? In the paper class, you have written 20 full papers so far. 20 full papers, and all are discussed, and marking schemes are given. Everything is completed, right? 20 papers means now, as new questions with me, with my model questions, you have written 20 papers means that is 1000 MCQs basically. 1000 MCQs, right? So in terms of essays, right, 8 into 20 means 160 essays are there in the papers, right? And 80 structured essay questions are there, right? So practice those things again and again. And here I started on YouTube. I started a S2A discussion, right? I can't remember the exact month I started, but now I have done 25 days of S2As. 25 days of S2As, and in these 25 days, we have discussed MCQs, structured essays, right? And not only that, I utilize it to other paper discussions also. Paper discussions කියලා කියන්නේ like support seminar papers and provincial papers, right? For that also I use it, right? වගේ වැඩ ටිකක් කරා. It's 25 days කියලා කියන්නේ there are 25 sessions, right? All the playlists are still there on YouTube, right? ඕන තරම් බලන්න. Doesn't matter whether you are attending to my class or whether you are attending to different classes, doesn't matter now at this point. Using something, right? Getting your thing done is the focus here, right? ඔයාගේ වැඩේ කොහොම හරි කරගන්න ඕනේ. You have to get your thing done, right? ඒක ඔයා මගේ වීඩියෝ එකක්ද බලන්නේ, ඔයා නැත්තම් වෙන වීඩියෝ එකක් බලනවද, වෙන සර් කෙනෙක්ගේ ඩිස්කෂන් එකක් බලනවද, එහෙම නැත්තම් වෙන කාගේ පාඩමක් ලෙසන් එකක් රිෆර් කරනවද, doesn't matter as long as you do this properly and you go through, right? Doesn't matter. ඒ නිසා අයව මොකුත් බලන්න එයා හිතන්න එපා. ඕන තරම් ඔයාට ඕන තරම් resources තියෙනවා. You have plenty of resources. ඕන තරම් ඒ දේවල් use කරලා බලන්න, right? And then we had 5 practical seminars. Right? Starting from mechanics, waves, optics, thermal and electricity, right? And all practicals are covered. You have covered all practicals with me in live sessions, right? Right? And then I gave you question analysis. Right? Those videos are still there on the channel, right? All practical seminars are also there on the channel, and you can find this as or under the playlist experiments, right? Experiments කියලා playlist එකක් දාලා තියෙන්නේ. ඒ playlist එකේ practicals 30 ගානක් ඇති ඔක්කොම ටික තියෙනවා. Right? Experiments ඒ list එකම තියෙනවා. Right? And yeah, ඔය ටික ඔක්කොම ටික අපි දැන් cover කරලා ඉවරයි. Then now at this point, what you need to do is practice more questions. Practice more questions, right? Now let me stop sharing. Right. Practice more questions, right? Always you have to grab the question types. Question types grab කරගෙන මොතර questions practice කරන්න. Question types තමයි ඒවා grab කරන්න ඕනේ. Question types, whether you know this type of question or not. Right? ඒ question type එකව දන්නවද නැද්ද? ඒක තමයි දැන් මෙතන තියෙන point එක. Why question type එක දන්නවනම් that's totally fine. That's fine means that's better. And if you don't know that particular question type, then you have to improve that type. You have to work on that question type and improve. Right? Okay. Then don't ever think to give up this game at any point, because now we are just 5 days from the exam, and sometimes there can be students you are still not that confident enough to go to the exam, but don't worry, get the maximum from these 5 days and go to the exam, right? And don't ever think of giving this up at any point, right? Giving up is not the thing, right? Give up කරා කියලා වැඩක් නැහැ, right? ඒ නිසා ඔයාලට කරන්න පුළුවන්, understand your potential, know your true potential and do this, right? And when you are moving forward in your life after A levels also, right? After A levels you are going to exposed to the society here, right? Or society exposed වෙනවා කියලා කියන්නේ the main society, right? The main society. Then you will be the what we call the lowest layer of the society, right? Then you have to make your own decisions, right? You have to make your own decisions. There are many things. Many responsibilities. Responsibilities are building up, right? So many things. Right? Then finally, now we have just 10 minutes more. To finish this off now. So finally, what I'm saying again is about physics and about the exam, right? Panic වෙන්න එපා, don't be panic at any point, right? ඔයා දන්න දේවල් හැම වෙලේම පුළුවන් තරම් කරන්න, and question types practice කරලා exam එකට යන්න පුළුවන් තරම් ඒවා practice කරලා exam එකට යන්න, right? Timetable එකක් එක්ක වැඩ කරන්න. ඊට පස්සේ after A levels when you make your decisions, right? Think of the decisions that you are going to make twice, thrice, or many more times, and make your decisions, because most of the decisions that you are taking after A levels cannot be reversed, right? Most of the decisions that you are taking after A levels cannot be reversed. එතකොට ඒවා හොඳට හිතලා ගන්න ඕනේ decisions. හොඳට හිතලා ඒ decisions ගන්න, right? මොකද එහෙම නැත්නම් ඊට පස්සේ ඔයාලට ඒවා reverse කරන්න බෑ. Then at some point you will have to regret, right? Don't let that happen, right? Regret කරන්න දෙන්න එපා ඔයාගේ decisions වලට, right? Then now from my side and the other side, our class, I have delivered my best to 26, right? And now up until this moment, now we are here in a discussion today, right? We are in a discussion. This is the last discussion, right? And there are some other scheduled videos on past papers also. They will be published. They are scheduled, right? They will be published in the coming days also, right? ඒවත් බලන්න, හැමදේම බලන්න, right? බලලා the ultimate goal or the ultimate target that you should have is, now at this stage, is finishing your A levels with colors, finishing your A levels to your expected or the anticipated level, right? Finishing your A levels to the anticipated level. ඕක තමයි මේ වෙලාවේ තියෙන්න ඕනේ, right? Then thereafter you can make your other decisions, what you are going to do after A levels. And from my side, if you got any questions, if you have any doubts, anything these days, or maybe if you got something to clarify from my side after the exam also, right? You can always contact me through my numbers. That's totally fine, right? That's totally fine, and I'm always happy to help you out, right? I'm always happy to help you out in such cases, right? always happy to help you out, right? Then about the life that you are going to get after A levels, right? That's exactly where you are going to start your life, because now up until A levels you have a very nice and smooth, organized path, nice, smooth and an organized path, right? But now after A levels, we don't have such kind of an organized path, right? Your friends, right, colleagues, and everyone are moving in different paths by their own, right? They have different paths. Some of you might be uh, going to the universities from the first try. Some of you might be doing a second attempt, second try, and some of you may be going to a job after first try, and some of you may be going to other courses, maybe migrating. So there are different things. There are different things, right? There are different things. So whatever the decision you make it with make it without regrets and make it with uh, confidence, and should be a solid decision, as you don't need to reverse or as you don't need to regret at any point, right? Analyze the situation, then make decisions properly, right? And then uh, about the about the university entrance and the other courses, right? If you need to get any idea from my side, any inputs from my side, I can always help you out about the course selections, right? Preference list, right? Those things. I can help you out if you wanted to, right? Feel free to contact me through my number, right? And now your batch, right? Sometimes you might not have seen me, right? Now, if you are a physical class student, we have met in person, but if you are connecting with me in the online class or sometimes in these YouTube sessions, right? Sometimes you might not have seen me, right? Now, I don't know who you are because I haven't seen you, but you know who I am because you have seen me in the classes, right? So if you see me somewhere, right? If we cross our path somewhere, feel free to talk at any point. Uh, Feel free to talk to me at any point. So we can get to know, right? Because now sometimes we might not meet again after today, right? Might not meet after today once the class is finished, right? You'll be seeing me on social media, YouTube, and those platforms. That's true, right? Have in person number again? Sure na? That's not true. One physical class. Now, even though sometimes we may be living in the close proximity, same area, but sometimes we might not get a chance to meet each other again, right? That's how the life is, right? That's how the life is that we have to bear up. All right. Then about the other things coming up in your life, right? Always there will be problems because life is all about problems and solutions, right? Life is all about problems and solutions. Always we'll have problems and always we'll have solutions as well, right? So therefore, this is a battle or this is a game between problems and solutions, right? Otherwise, none of us are never going to get a streamlined, a smooth flow when we are moving ahead in our lives. එහෙම වෙන්නේ නැහැ. නිකන් ලස්සනට කිසිම ප්‍රශ්නයක් නැතුව එහෙම ඉස්සරහට යන්න වෙන්නේ නැහැ. එක එක දේවල් තියෙනවා. Right? But whatever you get as a problem, face it with confidence, right? And don't ever give up. කිසිම දෙයක් give up කරන්න එපා. And always have goals, have targets, right? And have timely targets. Timely targets means you should have targets like by the age of 24, I'll be doing this. By the age of 25, I should be this. By 30, I should be this. So likewise, have timely targets. Timeline එක target එකේ ඉන්න. ඒ targets achieve කරන්න. Right? Achieve කළා. Life එකේ ඉස්සරහට යන්න. Right? එහෙම තමයි වෙන්න ඕනේ. Targets තියාගන්න නිකන් target එකක් තියාගෙන වැඩක් නැහැ. Right? Say you have an academic targets, maybe financial targets. මොන targets උනත් කමක් නැහැ. මොනවා හරි targets තියාගන්න, but always keep your targets with a timeline. Timeline එකක් නැත්නම් ඒ targets වලින් වැඩක් නැති වෙනවා. Right? And work for the targets. ඒ targets ඔයාලට achieve කරන්න පුළුවන් වෙන විදිහට ඔයාගේ දෙන්න පුළුවන් maximum එක දීලා ඕන දැනක කරන්න. Right? And when you are in the society, right, except our what we call the inner circle, except our immediate circle, right, all other people are always trying to uh, make use of us, right? They are going to make use of us for something, right? For something මොනවා හරි දෙයකට අපි use කරන්න තමයි try කරන්නේ. So always be rational and uh, be what we call conscious in such cases, as once you have done science subjects, right? Especially you are a like you are a set of students with rational thinking, with good rational thinking, physics වගේ subject එකක් කරලා දෙන කට්ටියක්, right? ඒ නිසා මේ නිකන් අර silly decisions ගන්න එපා. silly decisions ගන්න එපා. කිසිම point එකක analyze කරලා rationally බලලා ඒ decisions ගන්න. right? මිනිස්සු use කරන්න එනවා නම් use කරන්න දෙන්න එපා. then if you know that you are going to be used, right, you better leave, right, you better leave, something like that. So don't let anyone to use you in your life, right? Don't let anyone to use you in your life when you are moving forward, right? And achieve your targets, and we'll meet again someday. If we meet again someday, right, we might be not on the same level as this, right? Definitely we are not, because now today is the last day you are seeing me as your teacher, and I'm seeing you as students, no? Right? Now, even though we met on one day, now the level we are in our lives might be different, right? You might be doing courses, degrees, jobs, right? So likewise, we are in different levels of our lives, right? And I'm always happy to see you, right? And happy to hear from you about the things you are doing in your life, right? So keep the contact, right? Dikana contact cheyagana. Now, even though the class is finished, right? Even though the class is finished, always keep in touch and keep the contacts, right? With me, right? And about my classes, about our classes, right? If you have anything to comment or anything to say, right, maybe positive or negative or whatever it is, any final thoughts you have about the classes, right, you can add comments to the video, or if you are using Facebook, feel free to add a review on the Facebook page. Reviews දාන්න all right. Then so finally we have come to the last minute. We have to end this before 12, right? End this before 12. So I'm going to leave at 12. So at last, what I need to say is, right, at last what I need to say is, right, don't ever give up, right? Win your life, and I want all of you to succeed in your life, right? Succeed in your life when you are moving forward, right? Succeed when updates then, right? Then results out of us results කියන්න, right? Then that's it. That's 12 now, so I have to finish this. Wishing you good luck and best of luck to the exam, right? Do your best and finish it with colors, right? Then I'm leaving, right? Leaving for the last day, last time. See you again, right? Then good night and goodbye. Good luck.